Hello everybody. Today this is the lesson 10 of C programming language that we'll be discussing today, that is operations on bits. Bits we have seen like till now, and we'll see what all operations that we can do on this. These are simply otherwise called as bitwise operators. Okay, so here we'll be seeing what are bitwise operators and what are the different types. As we see here, we have left shift operators, right shift, and we use and XOR and OR operators. And then we'll be simply looking at hexagonal net number system and what is the relation between hexagonal number system and binary number system, and go for a summary of the lesson. Yeah, bitwise operators. This is one of the C's powerful feature, and this has a bit manipulation operators. This is otherwise called as you see here, it's powerful feature, and it is a set of bit manipulation operators. These permit programmers to access and manipulate individual bits within the piece of data. That means all the bitwise operators can be used within within the small piece of a data, which gives for an effective program, and also that is permittable, or that is permitted into a program. You see few bitwise operators here along with their meanings. This symbol is used for ones complement, this is used for right shift, and this is used for left shift, and this is bitwise and bitwise OR and bitwise XOR. We'll see like why do we use all these operators, and what their result would impact on the program. Alright, these operators can operate upon ins or char and even float and double, and this can be numbered from 0 onwards, increasing from right to left as that of arrays that we do from zeros onwards, that we start array notations. The same happens with the bitwise operators as well. Here, when you come for right shift operator that we have discussed, it is given a representation by 2 greater than symbols. Here, if you have to look at a simple example of right shift operator for a character, here I gave right shift for 3. That means if you have name of, for example, take my name as Kavya. If you want to right shift for 3 alphabets, KAV, it is right shifted, and the rest of the alphabets is given as an output, as if we simply wanted to print out, give a printf statement for right shift. Otherwise you can perform any other operations as well. Here you give ch for 5, that means it will shift 5 bits placed on the right side. And if you go for a simple example here, I declared int values, I gave j and k as a variables. As for a decimal, that is same that of binary, for user to give an input, then that is in place of we performing scanf all the times till now, we simply use here a show bits operator. This is otherwise used for scanf purpose, and simple usage as directly without we need of using %id and all. We can simply directly store the I value. Now using the help of for loop, we'll be writing a simple expression here. K is equal to I right shift of j. That means when the value of I is right shifted to j, okay, then we give a printout of I value and j value. Alright, and that is again we use a show bits of value k and then give a return 0 value. When you come for the left shift, almost everything will be same, only the difference it is shifted to the left side. As we see here, everything is like almost that of right operators. Here the only difference from the previous program is condition here changes, where k is equal to I 2 less than symbols of j. Okay, the output that we have seen for the left shift operator will be like this. Alright, for decimal number of 5225, the binary number is this. Okay, when you do for a left shift, that means left side 3 digits are shifted, and then for 0 shift the value will be same, for one shift, this here it is actually 3 zeros, and what happens with the left shift is 1 zero is removed and shifted to the right. Here we as a result get only 2 zeros, and then the other zero is shifted to right. When you go for shift 2, 2 zeros are shifted to right and 1 zero is just here. The same happens for shift 3 and shift 4. This is the same case when you look at right shift operator, but the only difference is the shift will be of right side of a binary number. Alright, when you go for a bitwise AND operator, this operator is represented with the symbol AND or ampersand, and this operator or operation can be performed only on two operands, like only if you have left side operand and right side operand, the AND operation can be performed. Okay, while using this, two operands are mandatory or compared. These are compared by bits. Like for example, on right side I have 2 bits, on left side I have another 2 bits. These 2 bits are compared, and only then the AND operation will be taking place on these two operands. Okay, that is most same for character and integers. If you see rules for bits, if the first bit is 0 and the second bit is 0, the final bit will be 0. If it is 0 and 1, this will be 1. If it is 1 and 0, this will be 0. If it is 1 and 1, this will be 1. This means we can simply tell that only if both the bits are ones, the output will be 1. All the rest of the thing output is 0. This is simply you can compare with the what do we say, truth tables that we have learned in our schoolings and all. Alright, this is represented as a truth table, yeah, as I said you. Fine. When you go for bitwise OR operators, as we see in AND operators, only if both are true, the output will be true. All the rest of the cases, output will be false. Whereas in OR operators, this is another important representation. If either of the one is true, the output will be true. That means when you give 1 0, the output is 1. When you give 0 0, the output is 1. When you give 1 and 1, the output is 1 again. It means in all the cases the output is 1. That means for anything you perform, for any comparisons you give OR operators, the output is true always. If you see doing OR operation on bits, the resultant will be like this. This description takes some time, and so if you really want to know how this description is all about and how you get this output, you can give a comment on the below my video, and I'll make sure that I'll get back to you with the description. Alright, and this is usually used on a particular bit in a number. Like for example, only these many bits can be used, or a few more bits can be used. We cannot use them on a huge number of bits. When you come for XOR, XOR is quite opposite to OR. That means when you say XOR, it is represented with this symbol, like standing greater than symbol, and it returns 1 only if 2 bits is 1. Like for example, if any one of the bit is 1. Okay, for example, here I say 0 and 0, both are zeros, so the value is 1. Both are ones, the value is 0. Quite opposite to whatever we have discussed for OR. If we go for a simple example here, so I'm using a XOR operator on B with the 12. So what happens here is you give a direct printout of B value before you perform XOR operator, and when you perform operator you'll get the value as 50. Okay, this gives the direct input. This is because when you compare the values of B and value of 12, you will be getting these outputs. Alright, hexadecimal system, this system is very similar to that of binary system that we use. Binary system contains 10 as a base, as that we can easily discuss, as that we already knew. Decimal numbering system is containing 10 as base, binary is base 2, whereas in hexadecimal the base is 16. Okay, since to know how this base 16 is described, we'll be discussing about hexadecimal systems. In this hexadecimal systems, the values are given from 0 to 9 for 10 and A to F for the rest 6 um, base elements. Okay, the continuation will continue for rest of 0 to F, whatever combinations that we consider. Here, for decimal number, if you have to represent 342, you'll simply tell us 300 times and 4 tens and 2 as one time, whereas that of in hexadecimals you'll be writing 3 as 256 times, because that is a square of 16, 4 as 16 times, square of 16 again, 16 again, and then 2 as one time. This is how the major difference that you can differ between decimal numbers and hexadecimal numbers. When you have to know the relation between binary numbers and hexadecimal numbers, this is the relation that we usually use whenever we calculate or wanted to know the values of hexadecimal numbers in binary. If it is 1 and 0 in hexadecimal number, the value of binary is always 0. If it is 7, value will be 0 1 1 1. If it is F, value will be all ones. All the rest of the things are skipped because it is very simple that you write 0 all binary values corresponding to the normal hexadecimal values. Coming to the summary, we have gone through the bitwise operators including right shift, left shift, bitwise AND, OR and XOR. And right shift and left shift are usually useful in eliminating bits from a number, either from left side or right side. And AND is used for testing whether both of the bits are on or off, inputting off in a particular bit or directly giving on. And OR is used to turn on a particular bit. For example, if you want particular bit to be operated, you'll be using OR operator. And XOR is used for almost same as that of OR, but in the complete opposite way, whereas the resultant of X and OR and XOR will be quite different. Okay, all this all about today's lesson, that is operations on bits. If you have any doubts at any point, you can surely put a comment below, and I'll make sure that I'll get back to you with that doubt and make sure that your doubt is cleared. Thank you.